Hi, well, welcome you guys. I hope you guys are excited to hear about the California Vultures today. So today's we're gonna have Alex Eagleton, who got her bachelor's in science from Cal Poly Pomona, and during her time as an undergrad, she signed up as a volunteer at a raptor rehab center where she began to shadow Dr. Pete Bloom. While shadowing Dr. Pete Bloom, she was able to learn more about raptor research, and her interest in passerine birds and raptors grew. After she received her bachelor's in science, she continued her studies at Cal Poly Pomona, where she received her master's in science in 2021. She began working in the environmental consulting world as an on-call biologist after receiving her degree. And a month later, she began working for Endemic Environmental Services, where she currently is at now, and where she is now a full-time project manager. And I also want to mention that she is an amazing birder. I've definitely have learned a few things from her. And so I'm just really excited to hear a little bit more about the research that she did as her master's. And so with that, I would take the floor to Alex.
Oh, thank you for that nice introduction, Anita. I will go ahead and share my screen and then try for full screen. Okay, cool. Does that look good? Okay.
Yes.
Cool. Great. Well, thank you everybody for coming. Today I am going to talk about some research on the effects of lead, as in the heavy metal, on turkey vultures that are captured and studied in California. So in order to kind of tackle a study like this and a presentation like this, ecotoxicology seems to need a lot of background information, because not only do you have the study species or whatever system you're using, you have the toxicology, the mode of toxicology, a little bit of chemistry, which I'll try not to dive too deep into, and then, the effects. So starting out, from the bottom up, lead is a pollutant that can cause serious health effects. So environmental lead has been an issue historically, globally, but just focused on United States and California. We can think of like past instances where lead was getting emitted from, factories. You've heard of leaded gasoline or lead in paint. And so these are all modes in which lead can enter the environment, as well as through lead ammunition. And so the problem with this is if lead then gets into a biological system, it has detrimental health effects. It affects multiple body systems. There can be liver damage, kidney damage, because of its similarity to calcium. It has neurotoxic effects. It has effects on hemoglobin and can cause anemia, and a whole array of other things. And so not only does it cause these effects, but it can also lead to oxidative stress. And so in this talk where I'm speaking about the effects on turkey vultures, the effects I'm measuring are going to be mentioned. Oxidative stress is what I'm measuring, like how these birds are being affected. So lead, this heavy metal, has a 2+ charge. And when it comes into contact with an atom, it rips off the electron, causing a free radical. And the problem with that is that free radical now is in need of electron and will bounce around the body in interacting with other molecules and causing damage to them. And so basically, lead can cause oxidative stress by creating this reactive oxygen species that then needs to cause damage in the body, or feels the need to. Usually what happens is reactive oxygen species are created and an antioxidant will come in and neutralize it. Unfortunately, with lead, an excess of lead or any other thing that causes reactive oxygen species in the body, it can overwhelm the antioxidant defense system and then cause oxidative stress. Now, then when oxidative stress occurs, that can cause a whole slew of other problems, including damage to DNA, damage to phospholipid bilayer, and just degeneration of cells and cell death. In addition to lead causing oxidative stress, while we're thinking about the focus, which is turkey vultures and it's just birds in general, migration can lead to oxidative stress. So, reactive oxygen species are something that are generated naturally and are usually neutralized by antioxidants. But as birds migrate, their metabolic rate increases, and there's an additional increase in reactive oxygen species. So then that could be something that also overwhelms the antioxidant system and creates oxidative stress. So kind of shifting back to lead exposure. So we have lead exposure and migration potentially causing oxidative stress. So going back to how lead can get into a bird and then maybe cause that. Raptors have been known to have problems with lead toxicity. And it is specifically because of opportunistic scavenging. So this is a picture of like the neck of a deer after it has been hunted. So this deer has been shot, the lead bullet hit it and expanded. And then you can imagine a scavenger can come and eat at the carcass and then ingest the lead directly. So that direct ingestion then causes the lead to enter the digestive tract and leach into the body. So we know about lead very well from the case of the California condor. It's a really famous example, both of the detriments of lead toxicity as well as like a really heroic effort to recover them. Their populations were crippled by lead ammunition, and that's been shown in multiple studies that is the main cause of their decline. And coming at the late 80s, the last California condor was actually captured from the wild, and it took an incredible effort to do a captive breeding program and reintroduce them. But 30% of condors that are captured annually indicate that blood lead exposure is still like in their blood. Exposure is still happening. There's measurable lead in their blood even today because there's a really strong monitoring program on these guys, and you can see that they have a ton. It's something that we still are worried about. So since we're going to be talking a lot about lead and we're going to be doing some numbers, micrograms per deciliter is like a really common dosage that you hear about. And so here's some examples. There's not really like a full, sorry about that. There's not like a full, list or chart anywhere because every body system is different. But lead in any biological organism, like the ideal amount would be 0. It's not something the body makes. It's not something the body needs. So that would be the optimal level. The CDC action level for like children and like that may have ingested it or have had contact with lead is less than 10 micrograms per deciliter. So after it gets above 10, that's problematic for humans. And then moving into condor examples, 20 would be acute toxicity. 50 is at the level of condors where they have to bring them in and chelate their blood and basically put in chemicals that'll bind to the lead to take it out. And above 50 is usually when condors perish from the lead toxicity. So condors are going to be our really big example, just because they're really closely related. They're both new to turkey vultures. They're both New World vultures, and they've been really well studied because of their historical plight due to lead ammunition. So how are we doing on this regulation of lead? So thinking all the way back from factories spewing lead and leaded gasoline, you see like it says unleaded now. Here's like a brief history. So In 1970, the Clean Air Act was established. Moving on to about the 80s, regulations on lead ammunition for waterfowl hunting came about in the United States. I didn't really mention, but if there's just shot on the ground in lakes and ponds, waterfowl will go down and eat it for roughage. So it is also a problem for waterfowl. Moving on to focused in kind of California, focusing on the condor. Lead ammunition was banned in 2008 in the range of the California condor. So no hunting with lead shot allowed in that range. And then really relevant to us here, in 2019, the state of California set up a statewide ban against lead ammunition. So taking all of this into account, I wanted to examine both examine in the turkey vulture both the exposure that these birds are getting to lead as well as the effects of lead. And so with regards to exposure, my question was, are migrant and resident populations of turkey vulture exposed to different amounts of lead? And in regards to effects, how does lead and migration affect oxidative stress levels in vultures? So the migration component is really crucial to this study, because as you heard, lead can cause oxidative stress in vultures or in birds in general, but so can migration. So in order to investigate one, you must investigate the other if they're both exposed to lead and migrating. So you can see here there's a map of the general range of the turkey vulture across North and South America. So what we kind of have here is a really wide distribution, and turkey vultures will not migrate north, or they're kind of like the typical bird where they go south for the winter, and then in the spring they're going to come back up north and breed in the northern latitudes. But additionally, there are pocket populations that don't migrate, and they're resident birds that stay there year round. And so for measuring the exposure to lead and measuring the effects of lead, I thought it was important to measure both populations and compare them to one another. So in regards to migrant versus resident turkey vultures, I have three hypotheses. We had three hypotheses for the study. And the first one is that lead exposure would be higher in migrants. So just going back to this graphic really quick. I don't know if you can see my mouse, but I guess you know where California is. If we have a state ban on lead in California, one can assume that in these southern latitudes, there's much less regulation on lead or lead ammunition, or even if there is like regulation on firearms in general. We've kind of heard stories of how that might not be followed. So birds that are coming up from southern latitudes and passing through California and then getting captured, the migrants, would have been exposed to lead in the southern latitudes, as opposed to birds that are staying in California and are protected by the ban, hypothetically. So this is a graphic that just shows like the theme of the graph I would expect to find, comparing the blood lead levels of migrant turkey vultures versus the blood lead levels of resident turkey vultures. So birds that ate lead ammunition in Mexico coming up would have blood lead levels that were lower than those that were in California the whole time. Second, my hypothesis is that oxidative stress would be higher in migrant turkey vultures. So the effects of migration and the effects of lead contamination would increase the oxidative stress in these birds that are migrating. The third hypothesis was that lead toxicity would increase the oxidative stress in migrants. So looking at a relationship between oxidative stress and lead concentration, you can see these two hypothetical curves are separated because the migrants would be migrating, have more stress, but it would be a sharper relationship because they had two factors that were affecting them and causing this the detrimental effects. So, Alex, how could you tell the difference between resident and migrant turkey vultures if some live in California all the time and some pass through? Well, we did this by temporal and spatial distribution of sampling. And so the blue there is going to be the resident population and the pink is the migrant population. So this Orange County area here has turkey vultures there year round. They have, there are tagged birds in the area that have been observed all months of the year. And the migrants, just from point counts, like, so this is a spot in Big Morongo Canyon Preserve, and this one is out more towards Palin. They don't have vultures observable year round. They are not there. And then during migration time, they stop over. And so that's when we tried to capture them. You can see here the pink and blue difference as well. So these are the trapping stints that we conducted and what we captured during each one. So during, you can imagine turkey vultures are migrating in late winter to early spring to try to get to some breeding grounds, and that's when we're trapping. And then in like the late summer is when we captured our resident birds. And I will get into it a little bit later, but we captured 41 resident turkey vultures and 7 migrant turkey vultures. And just off the bat, if you know a little bit about the biology of migrating birds, they do not like to stop, rest, or eat until they decide. So baiting a trap in an area that birds are year round and they're comfortable and can feed anytime, you end up catching a lot more. And even though we had quite an effort trying to trap migrants, I guess it didn't really line up with their preferred times to feed. So we were not able to capture as many, but we still did get some good data. So focusing on the capture, I really like this part. This is some of the fun stuff for me. So we used 2 different methods to capture the turkey vultures. This one depicted here is called a walk-in trap, and it's kind of like a big cage, and you put one vulture inside as like a lure vulture. Turkey vultures are naturally gregarious and really like to congregate. And so you bait the trap with something like a dairy calf carcass that would bring vultures in to eat, but you need one in the actual cage, this big giant thing that, you know, they're probably not so comfortable landing on, to kind of tell everyone else, hey, it's okay if you come in here. And so this is a picture of a really successful effort where 1 came in, 2 came in, and the more that come in, the more that go into the trap. It has a one-way door, which is shown here, and they kind of eat, and then when they need to reach in, they fall through and can't get out. The other type of trap that we deployed is a bow net. And so on the right, you can see it really well here. It's spring loaded, and we had a remote trigger to it. So we kind of set it up, baited it, and as the turkey vultures come near, as you can see from our trail cam picture, once they're right in the right spot, and there's no turkey vultures in the way that would get, you know, hit by the swinging arm, we press the button and it goes over and captures them. Then you just grab them out. They are a little stinky, I will admit that. Baiting the traps is a little bit stinky, but after a while you don't mind it, or you just get used to it. Or you don't, but I did. Yeah, so here's just another picture of our two types of traps. I thought these were kind of nice photos. So once we had the birds in hand, first thing that we did is put a patagial tag on them. So something interesting about turkey vultures, if you're familiar with bird banding, you can't band these birds. One of their defense mechanisms is to defecate on their legs, and that's not safe to put a band on because it will solidify like concrete and then eventually cause, harm to them and even limb loss. So this is like a sheep ear tagger or something very similar, and they have a unique identifier on there, and that's how we mark them. Something to note, my study is part of a lot larger study long-term for monitoring these birds and where they disperse and where they end up. So if you see a turkey vulture that has a patagial tag on it, take a picture. If you've got a nice camera, a long lens, take a picture, submit it to USGS Bird Banding Laboratory. Note what color it is, what characters are on there, and which wing it's on, or both wings. And that would help the study out a lot. I have to do my little plug. So after we marked the bird, we took a lot of morphometric measurements, which did not happen to be used in this study like directly, but we took some measurements like on morphometrics, and most importantly, we collected blood. And the blood that we collected was from the brachial vein and the tarsal vein, and it was used to analyze how much lead was in the blood, as well as biomarkers for oxidative stress. So to analyze the blood lead levels in these turkey vultures, the lab method we used was this Lead Care 2 kit, and it uses anodic stripping voltammetry to quantify the blood lead levels. Secondly, we did lab assays to quantify the oxidative status of these birds. And so I haven't talked about this yet. This is probably the most chemistry that we will get. So we had two biomarkers that we were looking into. It's kind of 2.5, but so there's glutathione and then there's protein carbonyls. And so how we decided to quantify the oxidative status is we wanted to use an antioxidant and we wanted to use a marker of oxidative damage. So the really common and crucial intracellular antioxidant is glutathione, or GSH. And when the glutathione, this is a little dark one, comes into contact with a reactive oxygen species, it is then converted into glutathione disulfide. And so by measuring the reduced glutathione and then the oxidized glutathione, we're able to see the ratio between the two and how much antioxidant was used up. Secondly, we looked at protein carbonyls. I wonder if I have a graphic. Okay, no, it's not important. But so basically what we did for this one is protein carbonyls, you can measure the carbonyl group, like the double bond oxygen, through a I can never say this, colorimetric assay, like with spectrophotometry. And basically when the reactive oxygen species come into contact with a protein, they get this stable group on there that's measurable and turns a color when we do a certain reaction with it. So antioxidant, glutathione, oxidative damage biomarker, protein carbonyls. So what we found was, yeah, I think it was interesting. So looking on the left here is a reminder of our hypothesis that we expected lead concentrations to be higher in migrant turkey vultures. And so we found that was correct. We did confirm that So if you look at this graph here, the bottom is the age and migratory status of the birds. And then on the y-axis is the blood lead levels. So just look at this one right here, the resident adult. And so compared to the migrant adult, we actually saw higher blood lead levels. So if you look at this dotted line, that's the 10 microgram per deciliter threshold for clinical poisoning. And then if you remember, the number should be 0, like the number that you would have an optimal level. They've never come into contact with blood lead. So the resident turkey vultures, some of them did have elevated blood lead levels, even though they lived in California, protected by the ban, from 2019 to 2020 to 2021 when they were captured. But the migrants that we were capturing had, none of them had undetectable blood lead levels. None of them were low. They were all mid, and then this high one, which is at 60 micrograms per deciliter. The reason why there's 3 kind of groups here, I wanted to show you. For the resident turkey vulture group, we actually captured multiple ages. We captured hatch year birds, just incidentally, second year birds, as well as adults. And just because so much change is like hormonally, just like growth wise, like lots of stuff is going on in growing birds. Our test here, like our non-parametric test, was just between the resident adult, just comparing the resident adult with the migrant adult. Secondly, moving on to a second hypothesis, we found that migrants had better antioxidant status than resident birds did. So that actually goes against what our hypothesis was. We thought, birds that are migrating, they have more lead, they have more stress when it comes to the load that migration might put on them. So, they're going to be doing worse. They'd have fewer antioxidants. That wasn't true. Migrant turkey vultures actually had about 25% higher glutathione, of the glutathione ratio compared to resident adult birds. Just to kind of be thorough, the ratio, as we talked about, of the antioxidant before it was used up and then after it was used up creates this ratio. So here, there's more available antioxidant in migrant turkey vultures, and less antioxidant that had been used up to neutralize the reactive oxygen species. So yeah, these migrants were better off as far as antioxidant status compared to their resident counterparts. Thirdly, we found that lead concentration predicted protein carbonyls in migrants. So we were expecting that there would be a relationship where if there was an increased lead concentration, the oxidative damage would be worse. And so we found that in migrants, but we did not find that in residents. So all of the age classes, hatch year, second year, and then after second year, or the resident adults, there was no relationship between how much lead was in the blood and how much oxidative damage there was. As you can see by all these dots that don't line up with anything. But in migrant birds, we found that the more lead was in the blood, the more protein carbonyls that there were. So to kind of make sense of all this, we did find that migrants had higher blood lead concentrations than resident turkey vultures did. And so that was something that we did expect to find. But it was also surprising to see that resident turkey vultures had, detectable blood lead concentrations as well. Those migrants had an increase, like they had more oxidative damage, but they actually had a better oxidative status. So just going back to this, we would expect, we were expecting that so we were expecting that they would have, so say for example, this bird that has this blue one right here, this blue point, they have about the same blood lead level as this purple point. And so that's a resident versus a migrant, and they have about the same blood lead level, but and the same oxidative damage. So what that means to me is that they are not being affected by this migratory status that they have. They're migrating, and their antioxidant system is exhibiting some plasticity in order to upregulate maybe the amount of antioxidants and the conversion and the enzymes that convert them back into an available status. So that was pretty interesting in regards to the migrants. And then on a broader level, I think that this study was kind of part of a larger body of work explaining how turkey vultures can be sentinels for environmental lead. So part of the goal of this study was to kind of test that 2019 California lead ammunition ban and see, you know, if turkey vultures within the state that never leave the borders are getting exposed to lead still. You know, if people are following this, if the lead ban is effective. This study is part of a larger body of work that could prove that directly with, we have some data of blood lead levels of turkey vultures pre-ban, and then during these birds would kind of speak to the blood lead levels post-ban, and being able to compare those, that's still a paper that's getting written up. But more importantly, turkey vultures generally, they're not a listed species, they're not a regulated species, they're kind of readily available to study. And so they can be a proxy for exposure in other species, especially something similar like the California condor. They could be a sentinel to kind of detect lead in the environment just by measuring them. And additionally, because we, you know, comparing the resident turkey vultures to the migrant ones, I think that part of the conclusion of the study is pointing towards the need for a flyway approach to conservation. So birds we know migrate, but a lot of times we do these tiny studies, or even regulation-wise, we do these regulations in this one area. We banned the state of California. That's great, but these birds live their lives in multiple locations. And so I think as far as like conservation and management strategies, we need to you know, think a little broader in those terms and work together to help protect species like this. So I had quite a lot of fun doing this project. Getting to work with these birds was super amazing. And I just wanted to thank everyone for listening. And I also wanted to thank all of my collaborators. I got so much support in the lab at Cal Poly Pomona from my advisor, as well as other graduate students that were there. My mentor, Dr. Pete Bloom, as well as some other collaborators like Miguel and Hal that really came together to help with, you know, the fieldwork side of things, the quantification of the toxicants, and then as well as some of the funding sources that helped get this project done. So thank you, everyone.
Thank you, Alex, for your presentation. Definitely learned a lot. If any of you guys have any questions for Alex, please feel free to unmute yourself and ask, or you guys go ahead and just put it on the chat. Yeah, it's really interesting study. So we do have a question on the chat from Sharon. She asked, did the vultures with lead levels of 60 milligrams per liter get treatment?
Oh, that is a great question. Um, so no. And going a little bit deeper into that, um, I think I might have missed mentioning turkey vultures are a lot more sturdy and hardy and resistant to lead than California condors are. So the vulture that had the high blood levels, I had it in hand and I didn't notice any physical defects, like no like signs of neurotoxic effects. Its weight was healthy when we cross-checked it after. It was only once that the sample had been to the lab and back that we found that out. So yeah, they did fine. That's also it also kind of points to why turkey vultures can be a good indicator for lead, whereas the California condors are much more fragile.
Yeah. There's another question from Cynthia. She asked, I know you say you can't put a ban on the vultures, so how does the tagging process work? Do you attach the tags to ensure they stay put without harming the birds or limiting?
Yeah, so those tags that we put on are permanent. I can show right here again. Yeah, so the tags are permanent. You take this red device here, and you pop one of these tags onto these two sides, and it's the same as like tagging a sheep's ear. We look for an area that has no feather growth on the wing. It's right on the patagium. It's like and it's mostly skin. So we're looking for, no blood vessels, no nerves, no feather growth. And it would be kind of similar to getting your ear pierced. It's pretty quick. And then it will remain in place, yeah, forever.
Thanks. I did have a question. So for your study, do you know if they're still continuing doing like this type of work, looking at the leads at took reverters? Like if you would want to like recapture the same ones that you study to see if there's been any changes in the lead in their system.
Um, yes. So the study in general is continuing. We are actually trapping Friday and Saturday to see if we get any more, and that would add to the body of work of post ban. Um, and then we don't. It's kind of surprising how many turkey vultures there are because I've tagged around 40 in Southern California in Orange County, and I've only gotten one recapture during that whole time. And there's more vultures that keep showing up that are just clean, no tag. The one that I did recapture, it had different blood lead levels each time. So um, it was it had a detectable level, like below a level below detection before, and then it had a slightly elevated one the next time.
So thank you. So I guess the older they get, the more lead could be.
There is an interesting thing with lead. So because it mimics calcium, with the 2+ charge, it gets stored in bone sometimes. So there actually is potential that when bone undergoes remodeling, your bones like will kind of increase in size and then like decrease with the regular bone remodeling that happens. The lead can be integrated into bone when the blood, it's circulating in the blood and levels are high. And then it can kind of go dormant a while. And when bone remodeling pops back up, it can get released. So it's kind of hard to measure exactly, or to know exactly where it came from. But usually when there's bone remodeling, it's like lower levels that would be released. It's not like an acute toxicity that we would measure.
Awesome. Thank you. Got another question from Sharon asking, do veterinarians obtain the blood? How do they get trained to draw the blood? It's actually a good question.
Um, I I took the blood. I wonder if I have a picture. I think I exclude it because people don't like to see it. Yeah, I don't have it. Um, yeah, so I was trained by a veterinarian to take the blood, as well as by raptor biologist Dr. Pete Bloom, who was also once upon a time trained by veterinarians. And so I was working under his Dr. Bloom's permit, and he has the authorization to take the blood. So we get a syringe like the same way. It's kind of the same way when you go to the doctor and they go right here on your arm. That's the spot that we look for in turkey vultures is we open up the wing like from underneath, so it'd be the other side of the bird. And we take alcohol and wipe it off until we can see the vein right as it crosses over the humerus bone of the bird. And stick in the needle, wait for it to fill up a bit, and then take it out, put pressure, and distribute it into our different tubes that we use for analysis. Some of them that have anticoagulant, some that have other, lysis buffer for genetics or what else you might have.
Awesome, thank you. Calvin, I see your hand up.
Yeah, just out of curiosity, how does defecating on your feet function as a defense mechanism?
Um, yeah, it's gross, so things go away. They also vomit, so that's like their main one. If they're in the trap and you're chasing them around, they're gonna defecate and they're gonna vomit. And I think my guess is the hope is they're just so disgusting that the predator doesn't want to eat them anymore. Um, it also helps keep them cool as well to defecate on their legs.
Hmm. Interesting. Did you ever had one defecate when you were trying to catch them?
Yeah. Oh, that's like a given. I've been vomited on like mid-air. It's like projectiling as I'm trying to capture it. Like it's kind of an initiation if you come out and work with me or anyone else that's handling raptors. They decide.
It's interesting.
Those are the kinds of things that don't end up in the paper.
No.
iPhone 2 is so grossed out. Um, Cynthia is asking, do they bite as another defense? Oh,
Yes, yep, they do. So they what we do, you can see in this picture actually, they have a sock on their head when we're processing them. And that is because it's something that you do with a lot of animals. It kind of keeps them calm, or at least doesn't give them the physical stimuli to react to. But if the sock is off their head and they can see something to bite, they will try to bite it. I've been bitten on my hand. Um, they've been bitten on my face. That was not a good time. It's not like horrible or it's gonna like destroy, but it'll cut you.
Sharon is asking, what was your major in college?
Oh, yeah. So for my bachelor's degree, um, I got a bachelor's in of science in general biology with an emphasis in zoology. And that was just something offered at Cal Poly Pomona. And then for my master's degree, it just says general biology, and kind of the way that I distinguish is I just tell people what my thesis was, and they know what I studied. So it included toxicology classes, ecology classes, stuff like that. But my school didn't really like differentiate into specialties for the name of the degree.
Sam is asking, why did you choose condors to study? And what was the impotence or origins? Do you have a personal connection?
Sure. So I think that this study was actually a if I think back to how I got involved in research, both raptor research and academic research through my school, this is kind of a combination of the two. So when I was in my undergraduate degree, I got connected with Dr. Bloom, my mentor, and I started learning about all types of raptors, bandy nestlings, red-tailed hawks. And he was starting this study in like the summer of 2016, where he needed somebody to check the vulture trap every day and help process. So I got a lot of experience doing that, just helping with vultures. I was really familiar. And then additionally at my university, I got involved with Dr. Bonasoli Alquati, which is a toxicologist, and I started helping him with toxicology and barn swallow research. And I ended up going to my master's because I wanted to be in his lab and study toxicology. And so when I was coming up with my master's thesis project, he Dr. Bonasoli Alquati gave me a lot of room to kind of come up with my own study. And so I took something I was really familiar with. You know, I can trap turkey vultures. I've spent a lot of time doing this. I'm interested in raptors in general. I think there was also a component of like, I know I can get a lot of these birds in enough time, like a good sample size in time to finish a master's project. That went okay, but that was kind of part of it. It was like I could catch enough. And then I was like, what can I study about them? And you know, the lead is the problem, a big issue that they're having that's relating to toxicology. So the study kind of came from there.
Nice. Thank you. Does anyone else have any more questions for Alex? Well, if you guys don't have, if there's any more questions, I'd like to say thank you, Alex, for giving a talk on your research, on your master's research project. It was definitely very informative and definitely got to learn a lot. And it's very interesting because I never really thought about, you know, vultures in that way either. So, it's very interesting. And I really hope that you guys got to learn a little bit more about what involves in doing research and working with birds and, you know, toxicology. There's a lot of stuff that happens that a lot of people may not know. So thank you very much for that information. I really hope that you guys could be able to join in next month for our expert series talks. We don't have a set topic yet, but please keep an eye out for the topic, date, and time. Okay. Thank you so very much.
Thanks, Anita. Thanks, guys.
Thanks, Alex. This was